Yes, ladies and gentlemen, today I want to take you to how to design a reinforcement concrete continuous beam. Carries GK 80 kilonewtons meters kilo, including self weight, and the QK is 60 kilonewtons meters. The beam is 250 millimeters wide by 8 millimeters depth. This one is not the effective depth. So if they say depth, they mean is the height of the beam. So we're supposed to calculate the effective depth. So, and there's a 3 equal spans of 6 meters. The beam also carries RC slab 2 millimeters thick, spans 4 meters, centers in the transverse direction. Design the beam for bending and shear if the grade 30 and the grade 460 are to be used for concrete and steel respectively. So we start by loading, and this table helps you to calculate the moment. This is the first row, which is 0.9 FL. FL is the first terms, the length. So if you have the loading, the UTO, you multiply by the distance to get the F. Then in order to use this table, you should calculate the loading, the UTL times the distance to get F. So this table helps you again to get the shear, as you see. Then we move on to bending. Then after bending, now we calculate the reinforcement area of steel. We start by K, and then Z, which is the lever arm, then area of steel. Then we move on to, after we calculate every moment at every support and every span, but for now we're using the greater moment to calculate the reinforcement of the beam. So now we move on to lastly with the shear, and then lastly we calculate the deflection, and we check if our beam is gonna, maybe it's not going to sag. So if our span is long, if the actual span is if the actual span is longer than the permissible span, it means our beam is going to sag. So that's why we check, so that make sure our actual span is not greater than our permissible span. Thank you. Don't forget to subscribe, share, and like. Thank you.